There you go. Okay. Now go back to 4.2 and see one more example. Okay. Then we'll go to 4.3 and there we'll find the domain of the rational function and we'll try to find how does the horizontal and vertical asymptotes look like. If you haven't heard the word asymptote before, no worries, we'll actually talk about that. But before that, let me quickly take one more example and graph it. Okay, so from 4.2 it will be the example 2 and the function is x plus 1 x plus 3 the quantity squared x minus 1. Okay, we want to graph it. Okay, so first of all, let me simplify it. If I simplify it by just expanding all of this and multiplying each other, finally I'll get this. If you try and don't reach this stage, you can send me email that, hey, I tried, but I didn't get the same as this. So I'll give you an idea how to solve this. But I think you should be able to reach this from the main function. Just make sure that you are using the properties right. Okay. So first of all, a quick question. It's not a +1 question though. A quick question. What's the degree of this? Oh, Pearson, very quick. Yeah, it's 4. As you can see, the highest exponent is 4. So the degree is 4. And from our previous discussion, the next question is, can you say how does this graph will behave in terms of the power function? How does this graph will behave? Which function will actually give us an idea how does this graph will look like from the previous discussion? Anyone? Oh, that's even, I know, but I mean y equals what? If you try, let's say for the previous function we said it's y equals x to the 5th. What happens for this one? Exactly, yeah, y equals x to the 4, exactly. This will definitely look like y equals x to the 4. Very good. So now, what's next? Next, we want to find the intercepts, right? So if you are trying to calculate the intercepts, what should you do? Of course, for the y-intercept, we can always plug in 0 in place of x. And if we plug in 0, this will be 0, this will be 0, all of this will be 0. The only thing we'll have is -36. So that means 0, -36 is our y-intercept. Okay? And for the x-intercept, although this is a huge function, once again, you know, with exponent 4, but fortunately, we actually have it factorized, okay? As we have it factorized, it will be much easier for us to calculate the x-intercept. And for x-intercept, we all know, oops, sorry, let me make the correction. It should be f of 0 instead. Okay, okay, so f of x will be 0. So that means our main factorized form will use that because, as I said, it will be easier to calculate, is 0, right? And we can actually get the real zeros from it, or the x-intercepts. So from this we'll get a -1, from this we'll get a -3, from this we'll get a 4. Okay, -1, -3, and 4. Exactly. Yeah, very good. So these are real zeros, or in other words, these are the x-intercepts. Now, as I said, Pearson, last time, that for x to the 5, we'll definitely have 5 solutions, but those, amongst those, 1 or 2 could be identical, and this could be seen here as well. You can see we have the exponent 4, so our intuition should say that we'll get 4 solutions, whereas you can see only 3, but the point is -3 is identical. Yeah, very good. Yeah, and the reason is it has a multiplicity of 2. Can you see that? The solution is actually this: -1, -3, -3, 4. But as this is identical, we can actually ignore this and write it like this. Okay, very good. Yeah. Okay, next up, let's see what you can do. Okay, turning points. Once again, a quick question: how many turning points will be there? Anyone else? 3, exactly. Yeah, 3, not 4, because our highest exponent is 4. So whatever our highest exponent is, yeah, we'll have 1 less than that. So there will be 3 turning points. Very good. Okay. Now, if we want to graph it, let's organize all of this. We'll have 3 turning points. Our y-intercept is at 0, -36. Our x-intercepts are -1, 0, -3, 0. What else? 4, 0. Okay, 4, 0. And this will look like y equals x to the 4th. Okay, although we don't really need that here because we want to graph it this time. Previously, we wanted to see which graph amongst those options gives us our given function, but this time we want to graph it, and simply because we are given this factorized form. If we are given this format, it's easier to graph. Okay, and for this section, math 126, I'll give you functions of this format so that you can graph. I won't give you this complicated format. Okay, don't worry, as I said before. Okay, let's move on. So from this information, we want to graph it. So first of all, let me use this small area so that I don't need to scroll down. I know that I'll have an intercept at -1, at -3, and at +4. Okay, I also know somewhere down here, let's say that's my 0, -36. I know that there is a point like this, okay, somewhere down here, and I know I'll have 3 turning points. Now the problem is, once again, if you remember, as we have tried example 1 from 4.2 in our last lecture, we don't really know where is our turning points, right? So the best way to have an idea of it is to take values within these intercepts. Okay, take values within these intercepts and see how does this behave. Okay, so let's try one from beyond this first. We'll try one between this, and then we'll try one between this as well. Okay, okay, so if I take one beyond this -3, let's take a -4. We can always take a -4. So if I take a -4, the functional value would be -144. So for, let's say that's my -4, it will be 144. So it will be way beyond this, right? So that means it looks like it gives me an idea that it will actually go down in this direction. -4, -2, and 2. Yeah, of course, it will work. I think so. Okay, next up, let's take a -2, which is within this interval. Okay, that means it's actually between -3 and -1. And for -2, we'll get a 6. So we can see within this interval, we have a positive value. So that means that's -2. That means that's here. So it's actually taking us here, right? Okay, and let's try one value between this. So if I try 1 is always easier to calculate. So 1 will give us a -96. Oh my God, it's going down again. So let's say that's my 1, 2, 3. So that's my 1. -96 is somewhere down here as well. Okay, so that means we can see the function is going down here, it's going up here, it's going down here. So that means definitely we'll have a turning point within this interval. Looks like that, right? Looks like we'll have a turning point here as well within this interval. Okay, now if we try to graph it, oops, sorry, I think I made a mistake. Do you have the calculator? Can you do it for me? What does the value of f of -4 gives us? Okay, let me do it here. -4 plus 1 is -3. -4 plus 3 is -1. So -3 times -1, and it's -4, -4. That means it's -8. So it will be 3 times 8. Oh no, it will be 24 instead. My bad. Sorry. So it will be positive 24. Oops, sorry. So this means this value for -4 will be positive. So it will be somewhere here. Somewhere here. Okay, for 4. Oh, the sheet has the values, right? Oh yeah, sorry. I can check that. My bad. I was actually trying, uh, in my head, imagining all this. Anyway, sorry. Yeah. Okay. So for 4, it will be somewhere here. And for, where is that? For 2, it will be here. So I think we can graph it now. Yeah, so the point would be -424. Yeah. So the point would be -424. It would be -2, 6. It would be 0.36, somewhere down here. Okay, so first of all, we know that we have an intercept rather at 40, somewhere here. So definitely the graph will come down, go to 0, -36. Let's say that's my 0, -36, although it will be actually lower than that, the point. Anyway, then we know that we have an y-intercept here. That means it will go there, it will go through it. Then we know it will intersect at -1, 0. We know that's an x-intercept for us. Let me use different colors for the intercepts. It will be easier to understand. Okay, so we know that graph will intersect it here. We know that graph will take us to -2, 6. That means here Then we also know we have an x-intercept here, so it will actually come down, okay? And then it will, as we know that there is no other x-intercept, so this gives some clear, this gives us a clear idea that it won't actually go past it, because we know that for 4 we have a value somewhere here. So that means if it goes past this point, it will have to intersect x-axis again. That is not the case, because we know these are the 3 x-intercepts we have. So what does this mean? Anyone? Can anyone give it a try? It will actually touch this and it start going upwards again. Can you see that? Okay, let me say this again. Let me use this graph, because that graph looks clumsy. That's 4, that's -1, that's -3, and that's 0, -36. Okay, so these are the intercepts. We know that this graph will go through these points. We know for -2 we have a value here, so it will go up. At -3 we have an intercept, it will definitely come to this. But my question is, how can you know, without any explicit calculation, without spending too much time, how can you find that whether it will go down from here or whether it will start going upwards from here? That means it will touch the point and start going upwards, or it will go down and again, because at 4 we know we have a point here, so somehow or other it has to go up. So what do you think, whether it will go down and again come back, or whether it will touch and start going up? It doesn't have anything with even, as you can see, because although we have an even exponent, it has went down. It has went down. It has gone down this x-axis. So it doesn't have anything with the exponent, because for if it was only x to the 4th, then it would have been always above this x-axis, right? But we have already seen that because of the other terms, it can go beyond or below this x-axis. Anyone else? We don't want to spend too much time while we're trying to graph this type of problems. So that means you don't want to calculate explicitly. We can always plug in 2-3 different points between this region and check where does this graph take us. But we don't want to spend too much time. We want to just well, we know it doesn't go down because there are only 3 x-intercepts and the next point is positive on the y. Exactly, that's the point. So if it goes down like this, okay, if it goes down like this, it has to come and reach this point. That means it will actually have to come back again, and which means it will have to intersect the x-axis again, which is not possible because we already know that we have only 3 intercepts for x. So this gives us an idea that it will actually stop here, it will touch the point and start up and going upwards. So that's your graph. This blue line, of course, is not a part of our graph. So this is our graph. This way, as I am discussing it, it's actually taking this much long, but you can actually graph this type of problems within 2-3 minutes, ideally in 5 minutes. Okay, this won't take this much time. If you understand the concept, calculate the y-intercept, calculate the x-intercept, as it will be given in the factorized format like this. It will be easier to calculate the x-intercepts. So calculate those You can easily see the number of turning points, and just take a couple of values within the x-intercepts. This should be this shouldn't take much time. This should be quite straightforward. Okay, any question from this? Because after this, we'll actually move to 4.3, which is really another interesting topic. Any question from this? I really like how you guys are getting this not so easy topic quite easily. You guys are getting this really easily. You guys are really getting the concept quite fast. I really appreciate it. I really think you guys are working hard on it. So keep up the hard work. I'll try to help as much as possible. Anyway, looks like no other question from it. So we can actually move to 4.3, right? Is there anyone who has still questions from 4.2? Okay, so yeah, let me